I'm moving on to example 7 on page 10. Let me erase all of this here. So example 7 on page 10. And this is about adjusting the number when our coefficient isn't in proper form. For example, here's part A. If we have 56 times 10 to the 4th power, that number, 56, that coefficient has too many whole numbers, too many digits for the whole number. What we really want it to be is, 5.6 something times 10 to the something up here. I don't know what it's going to be there. But 5.6 times 10 to the something. That's our goal. And it's 56. So what we have to do is think of a way that we can manipulate this without changing the value. Now there's a couple of things that we can do, and one of the greatest things is to be able to multiply something by 1. It never changes the value. And multiplying by 1, sometimes we have to be very creative in how we do it. I'm going to think about this. I'm going to think that 56 is too large, too much. And so I'm going to divide it by 10. I'm going to divide it by 10. And dividing 56 by 10, like if you had $56 and you had to split it amongst 10 people, or something like that, you just divide it by 10 and we get one decimal place reduced. It would be 5.6. But because we don't want to change the value, dividing by 10 has made that's a smaller number. We need to compensate by doing kind of the inverse. What's the inverse of, or the opposite of, dividing by 10? Multiplying by 10. That's right. So if we divide by 10, we also have to multiply by 10. And what that does is they counterbalance each other. So in effect, what we're really doing here is multiplying by 10 over 10. I'm just using one of these 10s for the denominator of 5.6 and the other 10 for this one right here. So I'm really multiplying by 1, by 10 over 10. I'm just doing it creatively. Well, let's see what happens when we do this. 56 divided by 10 is 5.6, and that's what we wanted. Times 10 to some power. Now, think about this. We don't see a power on this 10 right here. It's 10 to the 4th, yes, but times 10 to the... Yes, 10 to the 1st power. And we can use the product rule of exponents to say that these together become 10 to the 5th power. 4 plus 1 is 5th. So that's how we are able to adjust that particular scientific notation number. 56 times 10 to the 4th, again, it's not in proper form because that 56 is too large. It has 2 whole number digits and we only want 1. So we've got to make it 5.6, and we do that by dividing by 10. And then over here we'll multiply by 10, or 10 to the 1st power, to counteract that. So we add the exponents together, 10 to the 5th, and there we go. Let's look at example B on this. It's 30.7 times 10 to the 8. 30.7 times 10 to the 8. This problem is very similar to the first one. I again need to divide this by 10 because it's too large. So we can reduce its size by dividing by 10. And that means I'll have to compensate for that by multiplying by 10, or 10 to the 1st. So this will become 3.07. That's what happens when we divide by 10. We move the decimal point and make it a smaller number, slightly smaller, just one place over, times 10 to the, well, add the exponents. 8 plus 1 is 9. So that will become 10 to the 9th power. Very good. Let's do the same thing when we have, for example, 8, when we have negative exponents. It'll work very much the same. So here's example 8 on the next page. Here's A. We have 29.3 times 10 to the negative 5. Again, to get it to its proper form, we have to divide by 10, and in order to compensate, we have to multiply by 10, and I'll make that 10 to the first. The dividing by 10 does what we want, which gets us to 2.93, and times 10 to the, well, we've got to be a little bit more careful here. It works the same way, but we add the exponents. But negative 5 plus 1, think about it, negative 5, picture on the number line if you need to, plus 1, negative 5 plus 1 is negative 4. So that exponent is negative 4, which is negative 5 plus 1. We add the exponents. As a quick reminder, I'll circle them and put a plus sign right there. We add the exponents, just like we did up here. 8 and 1 is 9, but when we're working with a negative number, here, adding 1, it actually makes it, negative 4. Okay, part B, let's see, it says we have, wow, 158 times 10 to the negative 9. This time, we need to divide not by 10, but by 100, because it's got 3 whole number digits, and we only want 1. As I multiply to compensate for that by 100, I'm going to write it as 10 squared, or 10 to the power of 2, because that's still 100. I'm going to compensate for it that way. And so this will equal 1.58 times 10. Here, when we add the exponents, because we're multiplying, we'll add the exponents. Negative 9 plus 2 is negative 7. And so we have, on each of these, taken a scientific notation form, but it's not proper form, and made it proper form by adjusting the coefficient. Sometimes I have to divide by 10 to get a decimal point there and here. Sometimes we might even need to divide by 100. Okay? Let me move on to example 9, which is slightly different. I'm going to erase all this and go on to example 9. Looking at page 4.7-11, example 9. And these coefficients, 0.5, are too small because they have a 0 in that place. So 10 or 0.5 times 10 to the fourth, in order to balance this out and get it to be in proper scientific notation, I actually have to multiply it by 10 because I want to get that point, that decimal point one place over. So I've got to, this time, multiply by 10. And that means to counteract it, I've got to divide by 10, or divide by 10 to the first. What this does is 10 times 0.5 makes it 5.0, or just 5. But here, it's 10 to the 4 minus 1. Remember, the quotient rule tells us we need to subtract the exponents, top minus bottom. So 10 to the 4 minus 1, to complete this, that's 5, or maybe 5.0, times 10 to the third. In this case, the 0.0 part of it wasn't necessary. Here's part B, 0.37 times 10 to the 8th. We've got to adjust it. We want the decimal point to be right here. To get it there, we have to multiply by how much? It's too small. We've got to multiply to make it large enough, because 0.37 is a small number. We want to make it larger, the coefficient. That's what we're going to multiply it by 10. And we've got to then divide this one by 10 to counteract. So we're multiplying by 10 once, dividing by 10 on the other. And let's see, that'll get the 3.7 that we want, times 10 to the, here again, because of the quotient rule, we subtract. So we get 3.7 times 10 to the 7th. And I'm not going to make any kind of rule as to, how this coefficient should be, or from the previous, what the coefficient. I'm just going to go by what makes sense. If I got to multiply by 10, I've got to divide by 10. How does that affect things? I'm not going to try to make up any kind of rule. Well, in some cases you have to add 1, some cases you have to subtract 1, and it'll be way too confusing. Just think about it instead. Multiply by 10, then divide by 10. In this case, use the quotient rule, and we're there. Part C, is 0.206 times 10 to the negative 5. That's what we're starting with. It's in scientific notation, but not proper scientific notation. We want the decimal to be right here after the 2, which means, again, we multiply it by 10, and then divide by 10 to compensate. Now here, whoops, I made a mistake. I was thinking ahead and got that wrong. This should be 10 to the first power in the denominator. Okay, 10 times this moves the decimal one place to 2.06, that's good, times 10 to the, again, we're going to subtract exponent, negative 5 minus 1. This time it becomes 2.06 times 10 to the negative 6th. Yeah. Okay, this is called adjusting the coefficient when it's not in proper form. We are just about done with this lesson. The last thing that we have to do is example 10 on page 13. I'm going to erase all of this. And we're going to now go to page 13, example 10. And this, I'm going to do every single one of these. It's going to take a little bit of time. Please be patient with it. It's probably worth your time to do it. I'll go a little bit quickly with them, but I want to still spend some good time on it, so that that you get it understood, not just to gloss over it. What we're going to do is perform either multiplication or division with scientific notation. This is something that would happen in chemistry quite a bit. What we have in part A is this number, 1.2 times 10 to the 8th, times 2.7 times 10 to the negative 5th. What we're going to do, though, is, since everything really is multiplication, there's multiplication, there's multiplication, there's multiplication, use the distributive and commutative laws to switch and move things around however it suits us. And the best way that it suits us is to think of the coefficients, the 1.2 times the 2.7, multiply those two together, and separately, multiply the 10 to the 8th times 10 to the negative 5, those together. These will be the easiest because we know the product rule for multiplying with exponents. When the bases are the same, we add the exponents. That's 8 plus negative 5. In fact, I'll spend some time with that. 8 plus negative 5, which ends up being 10 to the positive third power. But what about the rest of it? What about this 1.2 times 2.7? Honestly, that's work off to the side. I'm going to multiply. 2 times 7 is 14. It's 4, carry the 1. 1 times 7 is 7, plus 1 is 8. Bring down the 0. 2 times 2 is 4. No carry. 1 times 2 is 2. We'll add those together. 4 is 12. 2, 0. 324. 324. But you might remember in multiplying decimals, we have to count up that there's 2 decimal places. So we've got to go 1, 2. This is 3.24. So let me write this out as 3.24 times this, which ends up being 3.24 times 10 to the third. And there's our answer. So again, we brought the coefficients together and did whatever operation. Here we had to multiply, so we multiplied those together. Found it to be 3.24. Here we got the powers of 10 together also, and then did what comes natural, which is, in this case, when we multiply, we add the exponents. We get this. Now, the next question, the last question might be, do we need to adjust the coefficient, or is the coefficient okay? Is it proper? And the answer is, yes, it's in proper form. So we're done. We're done with that one. Let's do part B. Part B is a division. Part B is a division. It says we have 3.5 times 10 to the 9th over 2.1 times 10 to the third. Wow. Just as before, we're going to separate these into the coefficients and the powers. Let me work with just the powers for a moment, just right here. That's 10 to the 9 minus 3, because when we have a quotient, we have to subtract the exponents. That becomes 10 to the 6th. So that's that part of it. Now the 2.1 and the 3.5, well, we probably have to do some long division. I'm sorry about that. 2.1 divided into 3.5. There's another technique that I'm not going to discuss here. It might be... Oh, okay, well... But one thing, when we divide by decimals, we need to move everything so that the outer number is a whole number, 21. So we'll make it 21 into 35.000. And when we divide, 21 goes into 35 once. I'm going to say 35.00. 21, got to subtract there. Better get a skinny pen here. Let's see, 4, 1, 140. 2 goes into that 6 times. 6 times 21 is 126. And we subtract, we get 14 and bring down the 0. Whoa, 140 again. That's 1.6. That's going to be 6 again, isn't it? And that's going to be the, same. So what we get here is a repeating number, and we'll usually take that 1.666666 and maybe round it off to 1.67. So this becomes 1.67 times 10 to the 6th. And again, we ask the question, do we need to adjust the coefficient here? Do we need to adjust it at all? The answer is no, because it's in proper form. Now, one way that we can also represent it and say, hey, I rounded off, so make it not an exactly equal to, but instead we can use these squiggly lines to mean it's approximately equal to 1.67 times 10 to the 6th. So we could do that. That's the, the 1.66666 would round this 6 here off to a 7, 1.67. Okay. Wow. Tough problem. Okay, let's go ahead and complete example 10. And so we're still on example 10 here. Part C. Part C says we have 3.5 times 10 to the 4th times 6.4 times 10 to the 7th. And again, the first thing we can recognize is that we can multiply the coefficients together separately from the powers of 10. So again, doing some scratch work off to the side, 3.5 times 6.4. We'll worry about the decimals in a moment. 5 times 4 is 0. Carry the 2. 3 times 4 is 12 plus 2 is 14. Bring down a 0. 5 times 6 is 30, so that's 0, carry the 3. 3 times 6 is 18, plus 3 is 21. And we get 0, 4, 2, 2. But because we have 2 decimal places, we get a decimal point right there at 22.40, or just 22.4 times. Now what are we going to do with these exponents over here? Because they're being multiplied, we add the exponents. 4 plus 7 is 11. And so that becomes our answer, 22. Oh, I made a mistake, didn't I? Did you see what my mistake was? I was a little bit fast. I better not put a box around that yet. Goodbye, box. What's wrong? Yeah, you caught it too, didn't you? Yeah. The 22.4 is not proper scientific notation. Oh, so here's where I have to adjust the problem. It's too large, so I'm going to divide by 10 to make it 2.24, and then I've got to multiply by 10 to the first. That's still by 10. So I have to adjust it this time. Okay, let's see. 2.24 times 10 to the 11 plus 1, 12. Now I can put the box around it and say done. Okay? That's letter C. Let's conclude this now with letter D. And I see we have 3.6 times 10 to the 6th divided by 7.2 times 10 to the negative 2. And it's kind of like this. We're going to just kind of separate it right here, but I want to write that out anyway. 3.6 times, or over 7.2, that means divided by 7.2, times 10 to the 6th over 10 to the negative 2. Let me do the 7.2 divided into 3.6. And as I mentioned before, we got to move that decimal point one place so that we get a whole number here. And then place as many zeros as we need to or want to. So let's see, 72 into 36. There's the decimal, go straight up. Won't go any time, so I'll make that a 0. 72 into 360. Man, I'm going to do like 7 and 36. So that goes 5 times. So let's see what we get when we put 5 here. 5 times 2 is 10, which is 0 carry the 1. 5 times 7 is 35 plus 1. Oh, look, 36. Oh, we subtract out 0.5. So we got 0.5 for this times, now let's see, let me do this one right here. That's 10 to the 6. With the quotient, we got to subtract the exponent minus negative 2. That becomes 10 to the 6 plus a positive 2, or 10 to the 8th. So that's what we get. Now, I was about to put another box around, and I remember what I did before, and I noticed that this coefficient is not in proper form. We've got to find a way to make it 5 point and get the decimal on the other side. Well, the only way we can do that is to adjust the coefficient multiplying by 10. 10 times 0.5. But to counteract that, we've got to also divide by 10 to the first power. So we're multiplying by 10 and dividing by 10. Multiplying by the 10 will give us the 5, or the 5.0. Dividing by 10 makes that 10 to the 8 minus 1, 10 to the 7. And now I can put the box around it and say we're done. Okay? That was tough. 4 tough problems there. Hopefully, let me see the problems I gave you here. Exercise 10. I'm glad you have to do it and I don't have to do it. Sorry about that. Anyways, there you have it. Hope you've learned a lot here. Go back and review this video if you need to. Go back and review by reading section 4.7. And hopefully you get a sense of it. All right? Well, I'm done. See you later.